If you've ever faced this situation, you're not alone. Your calculated pressure drop looks low, the pump selection looks correct, but on site, the actual pressure drop is much higher, and someone eventually says, "On paper, this should work." This is one of the most common frustrations engineers face, and also one of the least honestly discussed. Because the truth is simple: most pressure drop calculations are not wrong, but the assumptions behind them rarely match reality. Let's get one thing clear first. Pressure drop calculations are not lies. They are approximations. They describe how a simplified system would behave under controlled conditions. When we calculate pressure drop, we quietly assume a lot of things. We assume smooth pipes, uniform diameters, known roughness, stable flow regimes, perfect installations. None of these truly exist on site. Take pipe roughness, for example. In calculations, roughness is a number we assume, often from tables or standards. But in reality, roughness depends on manufacturing tolerances, weld seams, surface finish, aging, corrosion, and fouling. Your pipe roughness is guessed, not measured. And small changes in roughness can create large changes in pressure drop. Now consider flow regime. Calculations assume laminar or turbulent flow, something clean and predictable. But many real systems operate in the transitional zone, where flow constantly shifts. Transitional flow is unstable. Losses fluctuate, and calculation accuracy collapses. This alone explains many site mismatches. Then we come to local losses: bends, tees, reducers, valves, strainers, hoses. On paper, these are called minor losses. On site, they are often the dominant losses. A real system is not one long straight pipe. It is a collection of disturbances stacked together. Each one adds loss. Together, they add far more than we expect. And systems don't stay clean. Over time, pipes foul, oil degrades, scale builds up, clearances reduce. Your calculation is frozen at day one. Your system keeps changing every day after that. Installation is another silent culprit. Drawings show clean routing. Reality adds extra elbows, flexible hoses, adapters, and last-minute changes. The site never matches the drawing, and pressure drop pays the price. So when engineers say losses are much higher on site, they are not admitting a calculation mistake. They are observing reality. Here is the unfiltered truth. Pressure drop formulas are approximations. Systems are not. Good engineers don't blindly trust calculations. They question assumptions. They measure pressure drop on site. They leave margins. They design for reality, not spreadsheets. Strong engineering is not about perfect math. It's about understanding how real systems behave, and accepting that reality will always be messier than theory. This is Engineering Unfiltered. Real engineering, no filter.